Everyone, my name is Vijay Redkar, and today let's talk about practical application of generative AI, a practical use case in banking, specifically in the area of GDPR, which is General Data Protection Regulation, which also encompasses PCI, PII, and all the things that are related to data privacy requirement, which is a huge concern within concern and a huge priority in banking. As you know, we have already established solutions and have already established mechanisms to deal with such scenarios. For example, let's take a concrete situation here, and here we have this statement here. This statement basically talks about an amount of credit card payment for Mr. Gary Thompson, and it has his certain information, and then it also has an amount, SSN, EIDA, etc., etc. There are established mechanisms where we can figure out what is this, what are these fields here that are specific to personally identifiable information. These fields can be set up in our configuration, and then when we get some data like this, then we can always compare it with the configuration and see, okay, is there SSN? Yes, so this is a sensitive field, and then I will mask this field. But what happens if you have a situation like this? There are chances, there is a very good chance that your bank is a global bank and it works in 50 different countries, and so let's say Spain is one of the countries. You could as well get a transaction statement which has this. Now here you realize that it is the same text, but translated to Spanish. It has data elements here which refer to social security number, for example, numero de seguro social. It refers to numero de contacto, which is a contact number. For our traditional solution, we would need to have all this set up upfront. Only then will our traditional solution work. Now, if your bank is global, working in 50 different countries, then imagine the amount of setup, the upfront setup that will be required. And this is a continuous activity. It's not a one-time activity. This setup will be required only then, and only then will your actual established solution, the traditional approach, will work. Having said that, what is the alternative? Can generative AI or artificial intelligence help us in this case? Generative AI, as you know, works on large language models, so it already has enough knowledge and semantic understanding of the text that it is actually parsing, and hence it fits very well into this kind of problem scenarios. Moving further, we will talk about, I will refer to a Medium article, and we will walk through that on the suggested solution. This is a solution that I have implemented, and we will walk through the various components of this solution. We will also talk about the implications of this solution, and whether this really works. Does this really work in the real world? So this is my Medium article, which says BankNext case study, AI and LLM to solve the GDPR challenge. Here, first thing we realize is that in order for us to have this large language model or generative AI to work, we have to interact with interfaces, the inferencing engines like OpenAI, Gemini, etc. Now, which also means that we have to send our data to these interfaces, these networks which are outside our own network, which right there defeats the purpose of purpose of data privacy. Hence, this approach does not work right there. But does that mean we cannot move forward with generative AI in banking? Moving forward, let's look at how we can make this work. And from now onwards, we will talk about how we can apply generative AI and large language model approaches to have this set up within our own premise, what are the components that we will be requiring, and what we will be able to achieve with this setup, and what are the drawbacks of this. Okay, so let's move forward. So these sections here simply elaborate on the business scenario, the challenges faced with the traditional architecture. If you need to look at the traditional established architecture, it is listed here. This is Bank Next case study. GDPR challenges solved with Spring Cloud Gateway. Spring Cloud Gateway is one of the traditional approaches that we can use. This is the design of that. You can refer to that to understand the traditional approach to solve this problem. We will now focus on how to implement generative AI to solve our GDPR challenge. This section just elaborates on the capabilities of what we want that we just discussed. Okay, well, let's go through this architecture diagram, which enlists the most important component that we are going to need in order to implement this solution. And then we will see whether the solution works or not in the next steps. So at the very core of our solution, we have a large language model, large language server, which is locally running. So that itself solves our most important problem. Now we don't have to interact with OpenAI or any of the other external inference engines to get the processing, to move forward with the processing. The component that we can use is Ollama. Ollama uses a pre-trained model like Llama 2 in order to understand the meaning of the data that we are passing to it. So for example, the text that we saw in the previous example, that text, when you send it, it will understand that these are what these words actually mean. Now, just by itself, Ollama is not going to solve our problem. We need to tell Ollama, our server, what it needs to do and within what context it needs to provide the solution, and that's where our Chroma vector DB comes into play. A vector DB stores information as embeddings, and the most important characteristic of a vector DB is that it stores information and with semantic meanings. So when you send it a query, it is able to find out the most relevant, the most closest document, the most closest text segment which is stored in the form of an embedding, and retrieve that for you. So for example, in our case, our scenario is to detect given a transaction statement. Our scenario is to detect any personally identifiable information or privacy or sensitive data, privacy sensitive data. So that context is what we can save and store into Chroma DB. Chroma DB works with embeddings, and there are many different formats of embedding we will talk about the specific embeddings that we are using. This essentially sets up a RAG, retrieval augmented system generation model, a generation setup for us, and which we will be using for our solution. Rest of this architecture deals with the actual information that is coming, the data that is getting passed. We can think of this as a application among, it could be one of your 100 application which is producing data, and that data could be potentially PII sensitive. That data, when that data needs to be sent to this RAG setup of ours. How do we do that? We do it with the help of an orchestrator. This orchestrator is written in Spring Boot and Java, and it also uses LangChain 4j. LangChain 4j is a very, very important tool that is part of this architecture, which allows us to interact with the vector DB as well as our large language model. And this solution, you will also notice that the solution is created in Java. Most of the solutions that you will find out there are typically towards Python, and this is an attempt to create a working solution in Java, so that we can also have this option moving forward. So this is a high level overall setup of our generative AI solution. Moving forward, we will deep dive into how these individual components are set up and what it entails. One other thing I also want you to take notice of is that this is any application. It is interacting with our orchestrator. Our orchestrator is a simple Spring Boot application which has dependencies of LangChain 4j, and our application is running as a simple microservice on 8888. When it gets a request, first thing it does is it makes a request to ChromaDB to get the context. ChromaDB has, in our case, the context is to detect personally identifiable information as or information that is sensitive, privacy sensitive, and customer privacy information, which we want to identify in the text that is coming from here, in the information that is coming from here. So Chroma interacts with its embeddings and then gives us the most relevant rules that need to be that will be required for this scenario to work. Once that happens, our orchestrator then interacts with the Ollama local LLM server. This LLM server is launched on our local machine, and it runs on the port 11434. Once it hits Ollama server, here we are passing to Ollama server the raw text that came in, which is like the statement that we just saw either in English or Spanish. Along with that, we are also appending all the context that we got from ChromaDB. We will see this entire structure as we move forward. Once you pass it to the LLM server internally then interacts with Llama 2. Llama 2 is a pre-trained model, but Llama 2 by itself does not suffice. Only when we send the information to Llama 2 along with the context and the fine tuning that we added to it, only then will it respond to us with the right information that we need. Now we will move forward with the flow. So now that we know the important components that are required in our architecture, we will move forward. If you need, the entire application is available here in this GitHub repo. You can take it and there you can set it up on your local machine. What you would need is all these components which are within which are available within this application. You will also need a Docker runtime environment. If you need to see how this Docker runtime environment how it is, you can refer to my Docker runtime environment, which is listed here. All these are the details of my Docker runtime environment. Also, the machine that you're running should have a minimum configuration of 16 GB RAM, 50 GB hard disk storage space, and 4 cores. If you go with a machine that is with lesser configuration than this, then you will find that the response times will be much higher, and typically the entire operation may not even complete. Even on my machine, when I run this, it takes a while for the response to come back, and at times the RAM becomes quite full. The more powerful the machine you have, the better it is. Typically GPUs are preferred. Now that we know the basic hardware requirements and the software requirements, we will move forward with the actual flow. So what happens here? So our data producer or a transmitter generates text or generates information, and we will take this example here. This example is in Spanish and it has certain information. At this point, we are not able to tell which of this information is actually privacy related and falls within the purview of personally identifiable information. So what we do is, our goal is to we want generative AI to autonomously identify any PII fields that are in the input statement. So we take this information that is generated from our source system, we pass it on to our local large language model server setup, and then we will allow it to process it, and then we'll see what is the output. So we talked about context, we talked about RAG, and the entire context that needs to be provided for our models like Llama to actually give us the right information. This is the actual text that we got this is the actual data that we got from our source system. What we did is we constructed the context that came from Chroma and also prefixed it to it. So what we have done here is that we have told it that you are a helpful assistant, and the context that we have provided is that you are a helpful assistant. This entire activity is to detect. What to detect? Is to detect any information in this text that is personally identified, that can identify a person's information. And we also told the architecture how to respond. Once you find anything like that, you will respond with those specific fields only. So this at times the large language model responds in a way with a lot of data, and we don't want that. We just want the specific information, so we are just instructing it to do it. And just by doing this, we are providing it enough information to process this data and provide us the output in an acceptable format that we can further use for processing, for taking the next action. This is Chroma here. As we already talked about, Chroma is loaded with the embeddings, and these embeddings represent the context that we are that is required. LangChain4j is our tool that is used for interaction with the various components in the large language model. And RAG is what we formed. With all these components, we are able to set up a RAG environment, which is the crux of this whole solution. Ollama, as we said, is a large language model server which has inferencing capabilities. That means it is able to deduce, it is able to inference. The reason we are using Ollama here is because Ollama has this specific capabilities. If you had to use some other large language model server, those would have different capabilities. For example, GPT is more towards has a much better capability towards creative writing, creative generation, or another model like Medllama is more towards is more inclined towards towards medical information. You can, if your use cases are those, then you could be better placed if you had used those. But in our case, we want analytical, we want deduction, we want inferencing type of capabilities, and that's the reason we are using Ollama here. Yes, so and we will our whole goal is that given input and given the context, our inferencing engine along with the model and the vector database should give us the response in the format that we want, and to a high level of accuracy. We see this is the input that we want. This is what we have given it. We have given it the context here, and this is the output that it generates. Sure. So you see that these are the various components that it has identified as personally identifiable information. This is the name of the person. Although it was in Spanish, it was still able to identify it. This here 5CT1 is actually the EIDA number that is listed here. It was able to identify that this is also EIDA is also a personally identifiable information, and also it has identified that 764132 is a social security number. Although it is in Spanish here, it is still able to identify that this particular numero de sigo social is actually a social security. Also, it was able to identify that numero de contacto is the contact number. So you see, we are able to accomplish this use case. If we had to do this the traditional way, we would have to account for all this setup. We would have to have all this information in a configuration somewhere where our application can refer to, and then make the necessary processing. All that is made seamless and seamless with this generative AI solution, and we have also been able to achieve the goal of keeping the data private. That means processing the data within our own premise only. This is where the power, or this is where the real application of generative AI and solutions like this lie. We will move forward now, and here are the details on how this application is to be set up. At the very first, we would need a Docker runtime environment on your machine. Mine is a Windows machine. I have a virtualization environment and a Docker environment set up in the very standard way. I have already pointed you towards to the link which has my entire Docker setup. We need ChromaDB, and the way to ChromaDB, the easiest way to set up ChromaDB is to run this command, docker run and then ChromaDB Chroma. This will pull all the necessary image, whatever is required for that image for Chroma, and then it will launch Chroma on your machine, on your local machine, and it will start it up on the port 8000 here, as you mentioned here. Okay, so once Chroma is set up, next step is to launch the Spring Boot application. This Spring Boot application, as I told you, is available in the GitHub, and it is a standard Spring Boot application with all the dependencies available in the POM XML, the LangChain 4j, the Ollama server, the embeddings, anything that is required to interact with Chroma. All those dependencies are already provided in this Maven based application in the POM XML. Once you build this application and run it, the standard nvn clean install and java -jar commands, the application starts up, and it is able to connect to Chroma, and it is also able to interact with our Ollama locally running LLM server. Let's take a look at how the output is. So this is the output. This is the input text that we provided, to our LLM, local LLM setup, and this is here this is the output. The output was like this. It was able to identify that EIDA, SSN, and contact number are the fields that identify this person's information, and it has provided that to us. We've also mentioned to it in the context that to be concise, as well as to provide only the specific fields, and hence it has provided us these fields here. In addition, it has also provided an additional information about what it is doing, but we will come to that later on. Now we will look at this other example where we provided it the Spanish text. Now here, these are all the Spanish text data which it was able to interpret and then provide us the output here. It was able to tell us that numero seguro social is actually your SSN 7645, and EIDA is also personally identified information, con, cinco, cito. This is actually representations of numbers in words, and also it is able to tell you that that contacto, numero de contacto means contact number right here. So this is how we have achieved our solution by using generative AI. In the conclusion, let's look at the actual implications and how this solution works in the real world. We've already seen the positives. The positives are that with this solution we are able to effectively solve the GDPR problem in the sense that we are able to identify the fields that are coming in an unstructured way. If we had to do it in the traditional way, that would have required us to have this very elaborate and tedious setup, and always keep maintaining it. But here, with this inbuilt ability, semantic understanding of large language model, we have been able to achieve this seamlessly without any additional setup, and we got it to work to a high degree of accuracy. With the context that we provided, we were also able to tell it what we wanted to do, and it also provided information very close to what we had requested it to do. Also, you will notice that this is a Java based application. This whole interaction is Java based, and hence we've also accomplished this solution with Java compared to all the other Python based applications which are available, and very less Java information that is available out there. Data privacy, we have managed to, we were able to effectively also maintain data privacy by having the LLM server set up locally using Ollama. Yes, and it eliminated the biggest advantage that we got. The biggest positive of this approach is that for so many scenarios that we have eliminated custom coding. We don't need to code for data that comes in a specific format, or it is in a Spanish language or some other language, because LLM has an inbuilt capability of language and language interpretation, as well as context understanding, semantic understanding. We are able to exploit that power of large language model and accomplish our use case. Well, there are also negatives in this approach. Let's talk about those two. We just saw that in order for us to run this application, it requires very high computing resources. It requires GPUs. Typically, if I run this on my machine, it takes, even for a simple case, it takes about, for this particular case, it takes about 2 minutes for it to respond to, which obviously is not acceptable in a real world environment. For those, we would require very high powerful machines with GPUs running to get response fast enough. So there is a latency involved in there, because when we use the CPU, there is considerable latency involved in there. You'll also notice that despite the fact that we told it, gave it the context and told it provide the response only in this format, provide us only those fields, it still added its own additional text to it. So what happens is that although 80-85% it provided us the data that we need in the format that we need, and almost very, very close to what we want, there is still this other part that we have to work through. We may need to handle that part ourselves. You'll also notice that there are times when this information that comes back, let's say if I run it 10 times, there are times, maybe 1 or 2 times, there is possibility that it may come up saying that I apologize, I cannot do this operation because of so and so. That there is a possibility, and you cannot do much about that, because only thing you can control it is through the context and the augmented generation that you have provided it. But even with that, there is a possibility that the output that comes can come with response that is unexpected, incomplete in certain matters, and at times it could be totally wrong. So those are the scenarios that you will have to handle. You will notice that in a traditional approach, traditional application, this never happens. If we tell our application that this is the contract you have to respond in, and this is the structure, we will always get that response. It will not change that response. So that is the biggest advantage of a traditional approach, which is lacking here in this Gen AI approach. Obviously, whatever is the response, however confident we feel about the response, a manual review of the response is absolutely a must. This is required, because even though we may see that 8 out of 10 times we are getting the response, if the response in the 9th instance is incorrect, and we actually it is not able to identify even one field in that text that we provided it, then that means that that particular field in our next processing will go in as plain text to the subsequent, and which defeats the whole purpose. So a manual review is absolutely a must. This response that we get from Gen AI, as we get more and more powerful models, it is expected to improve and become much better. But at this time, this is what we are seeing, and we have to be vigilant about this and take care of these kind of anomalies here. Well, at the end of it, what did we accomplish through this entire exercise? Well, the first thing is we had a very good learning. We learned that our traditional approaches, what are the positives of it, and what are the things that are desired, that are still left to be desired. How those lackings can be complemented with generative AI, with our own local large language model setup, and how easy or versatile this approach is in order to solve a huge set of banking use cases that we see on a day-to-day basis. This GDPR was just one example. We could use it for many other cases, but at the bottom line is that when you use this approach, you have to use it vigilantly and with caution. With that, we will end this discussion. Thank you very much.